Engineers, planners, geologists, miners, and many other professionals work constantly, tirelessly, tenaciously, with precision and skill, 24 hours a day, 7 days a week, on one of the cross-border projects of the century, the Branabase Tunnel. All the different groups working on the construction sites and in the offices are like gears that mesh to drive this infrastructure project forward. Implementation takes place step by step, like the steady ticking of clockwork. The Branabase Tunnel is one of the largest infrastructure projects in Europe, as well as the longest underground railway connection worldwide. A goal Austria and Italy are working towards together is a project that will unite Europe. Once the tunnel goes into operation, the travel time for passenger and goods trains between Innsbruck and Fortezza will be significantly reduced. Travel time for passenger trains will be cut from 80 to 25 minutes. North and south of the Brenner Pass, this will be a significant improvement for residents and travellers. If you want to get past a mountain, there are two ways to get to the other side. Either by travelling over it with many steep curves uphill and downhill, or going straight through it underground. A lot of people are working on the Branabase Tunnel to build the direct underground railway connection between Innsbruck and Fortezza. A railway tunnel at the base of the Alps, offering the advantages of a flat railway over a total length of 64 kilometers. The Branabase Tunnel comprises more than 220 kilometers of tunnel tubes. Two main tunnels for the tracks with a diameter of about 8 meters and a cross passage every 333 meters. Between those tunnels and 12 meters below is a third tunnel, the exploratory tunnel, which is 6 meters in diameter. This is driven before the others to understand the nature of the rock mass and to find out exactly what kind of rock to expect. Once the Branabase Tunnel has become operational, this tunnel can house technical equipment and be used to carry out maintenance work. The 4 lateral access tunnels in Mullis, in Steinach am Brenner, in the Arental Valley, and in Ampass are necessary to advance deep into the mountain and excavate the tunnel system from there on several construction sites simultaneously. By the end of 2024, 180 kilometers of tunnels had already been excavated, which is more than 80% of the total. In Fortezza, the southern entrance to the Branabase Tunnel has been clearly visible since 2018. In Innsbruck, the northern entrance in the complex Sill Gorge construction lot, which includes the connection to Innsbruck station, was completed. Extensive rock consolidation works and slope removal were only part of the measures aimed at building a modern railway line here and improving an important local recreational area. A team of engineers, surveyors, and geologists constantly monitors the behavior of the rock mass. Nothing is left to chance. Construction management plays an important role in ensuring that construction proceeds safely and successfully. The tunneling methods used are state-of-the-art. Special attention is paid to environmental compatibility and sustainability. For example, during the now completed work on the Isarco underpass near the south portal in Fortezza, all the ground in the excavation area was frozen with liquid nitrogen so as not to have to change the course of the river. The shafts required for this work have already been backfilled, and the construction site area has been restored with over 50,000 trees and shrubs. The effort involved was enormous, but it was worth it. High-tech machinery and technical expertise are needed to ensure that impacts on nature are kept to a minimum. And since nature is always top of mind, environmental impact assessments are the basic requirement for the project. In order to compensate for the short-term impacts and repercussions, accompanying environmental compensation measures will be implemented along the project area during construction, working with local partners in compliance with the highest environmental standards. This is where the environmental experts and landscape designers come in. People who can both ambitiously and very carefully rehabilitate a stream bed. For example, at the Rednaunebach near Vipiteno. Create a biotope in the Kirscher Au. Create fish-friendly conditions in watercourses, as in Nevis or on the Sill, where obstacles that are insurmountable for fish are being removed. Or create a small recreational oasis, the Tantigut Moor in Innsbruck. A green roof was built on top of the Arental power station. Using the motto "Connecting and Protecting," the Branabase Tunnel Company has also designed and built an educational trail in the Padaster Valley in Tyrol, which emphasizes the importance of sustainability in the BBT project. The latest environmental compensation measure near there was the redesign of the mouth of the Padaster Brook, where it flows into the Sill River. Sustainability is also a priority during the construction of the Branabase Tunnel. For example, long tunnel sections are excavated mechanically with highly efficient tunnel boring machines, or TBMs for short. After the logistically demanding transport and no less demanding assembly in the confined space inside the mountain, 200 to 400 metre long mobile tunnel factories are created, which then work their way through the rock. In the TBM's backup structure, the precast concrete parts for the inner shell, the so-called tubbing rings, delivered on rails, are unloaded and transported further forward, where they are assembled into a ring. Even further forward is the rotating drill head, which cuts through the rock with its numerous cutter bits. In the control room, the TBM operator pays close attention to the direction in which the machine is travelling and ensures that everything moves smoothly. Jacking, segment removal, pull-up of the TBM backup, regular checks and maintenance work on the drill head, and then once again jacking, segment removal, and so on. The finished tunnel increases in length on average by 15 metres in 24 hours, depending on the rock conditions. The exploratory tunnel section in Austria was excavated with a machine whose drill head was used as an exhibit piece in Tunnel World in Steinach am Brenner. Also in Austria, Lilia and Ida are currently driving the main tunnel tubes. The precast concrete elements that are installed by the tunnel boring machines are produced directly on site at the construction site. This avoids tens of thousands of truck transports. There is no room for tubbing ring production on the construction site in Wolf bei Steinach am Brenner. Here, the precast concrete elements are delivered by rail via a dedicated rail link. This is because the two tunnel boring machines, Wilma and Olga, which have been in operation there since September 2024, require a large number of segments every day. More than 50,000 of them will be installed there as the inner lining of the two main tunnel tubes. In Italy, the tunnel boring machine Virginia has already reached the national border in one of the main tunnels. And the exploratory tunnel has also been completed by TBM Serena up to the Brenner Pass. When excavating short tunnel sections such as access tunnels, rescue tunnels, and cross tunnels, it makes no sense to use tunnel boring machines. More conventional methods are used in those cases, with drilling machines, explosives, excavator buckets, steel grills, and shotcrete. Although heavy equipment is a great help to the miners in their work, a lot of manual work is still required, The average excavation progress here is 7 meters in 24 hours. The two large connecting tunnels in Austria, which link the Inn Valley with the Vip Valley, were also excavated using blasting. Since rail traffic in Austria uses right-hand driving, whereas in Italy left-hand driving is customary, two overlapping tunnels were built deep in the mountain. This allows for uncomplicated crossovers with no need for complex switch controls. Drilling and blasting was also used to excavate a fault zone in the northern Viptal Valley. There, the so-called Hochstegen marble had to be stabilized using numerous consolidation injections in order to be able to safely excavate this limestone under high water pressure. Logistics is the be-all and end-all in tunnel construction, because the construction site deep underground is reached via an access tunnel, the main artery of every construction lot, so to speak, to enable the construction of the railway tubes in the first place. High-speed trains will one day roar through these main tunnels. At present, rail-bound supply trains still move through at regular intervals, carrying people and materials to the excavation fronts in order to drive construction forward. Whatever the manner of excavation, the excavated material is removed in both countries via kilometers of conveyor belt systems and taken directly to landfills. One of them is located in Eicha, Alto Adige, another in the Padaster Valley in Tyrol. This means that not a single lorry journey through villages is necessary. Up to 1/3 of the excavated material is recycled and used for concrete production. Everything else melts into the landscape, creating cultivable land and turning a steep valley in Steinach into a recreational area. And on the subject of security, the client, BBT SE, and the construction company rely on numerous safety devices, such as self-sufficient escape containers, in which an entire excavation team is protected even against the greatest dangers in a tunnel, fire and smoke, until rescue workers can reach them. Regular drills train both workers and rescuers. In Italy, there is a continuous connection from the southern portal of the BBT to the national border at the Brenner Pass. In Austria as well, the tunnel system will soon be completed up to the border. With the breakthrough between the tunnel stretches in Italy and Austria, the Branabase Tunnel project will have reached an important milestone. For local residents and other interested parties, however, many things remain invisible and hidden. All the more reason for us at BBTSE to focus on multiple information and communications channels, organizing tunnel and construction site tours, setting up information centers, and providing reports. Our commitment to fast, modern, and efficient transport routes contributes to climate protection and promotes rail as the mobility of the future. Our work will benefit both local residents and the entire population of Europe for many generations to come.